In this video, we're going to look at dividing whole numbers by a decimal. So just like when we talked about multiplying by decimals and how that was a little counterintuitive because we're used to the answer of multiplication questions being bigger, and when you multiply it by a decimal number, the answer is smaller. The same kind of counterintuitiveness applies here. We are used to the answer to a division question essentially being smaller than the dividend. We are asking ourselves, how many 2's can we take out of 8? We can take 4 2's out of 8. So what's weird now is we're asking ourselves, okay, we have 8. How many halves can we take out of 8? So here I've drawn 8 whole circles, split them into halves. So how many halves can I take out? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So 8 divided by a half equals 16. Try and let that sink in for a minute. It seems a bit weird, but because we're saying how many of these less than 1 pieces can we take out of this number, our answer is actually going to be larger. So based on what we were just saying, looking at this question now, how many halves can I take out of 10? You can probably guess their answer is going to be 20. Because we know there's 2 halves in a whole, and in 10 we must therefore have 20 halves. But how would we do this using our traditional algorithm? Because obviously our questions are going to get more complex. So I wish I had a good explanation for this rule. I don't, but it works, is if we have a decimal in our divisor, we need to get rid of it. So what we do is we know our invisible decimal in whole number 10 comes just after it to the right. So if we want to get rid of the decimal in our divisor, we have to make our divisor a whole number. We need to move that decimal over 1 place to become 5 rather than 0.5. If we are going to move the decimal over on this side of our equation, on this side of our question, we have to do the same thing over here. So I'm going to take that decimal and move it 1 place. Obviously, I need to put something in that spot to exemplify that. So I'm going to add a 0 and make my new decimal there. So now I'm actually just doing question 100 rather, divided by 5, which if we do the math, how many times can I take 5 out of 10? 2 times 5 is 10, minus equals 0, bring down the 0. How many times can I take 5 out of 0? 0. 5 times 0 is 0, minus equals 0. Our answer, as we suggested in our estimation ahead of time, is 20. We'll practice this rule in the next couple examples. So this example says, divide, give the exact answer written as a decimal. So 22 divided by 0.8. We need to make it so the 8 is a whole number. We are going to move the decimal place over 1 place here to there, and our invisible decimal here will also have to move over 1 place to here, making that 0 there. We can rewrite the question as 220 divided by 8. Do the regular math. How many times can 8 go into 22, or how many times can I take 8 out of 22? 2 times. 2 times 8 is 16, minus equals 4, 6. If you're having a hard time with that, 1, 12, 6. Bring down the 0. How many times can I take 8 out of 60? 7 times. 7 times 8 is 56, minus equals 4. Remember, our decimal point is here now, because we're going to need probably decimal. Bring down another 0. How many times can 8 come out of 40? 5 times. 5 times 8 is 40, minus equals 0. Now let's ask ourselves if this makes sense. 220 divided by 8. That's hard for me to visualize. I know, okay, if it was 240 divided by 8, it would be 30, because 24 divided by 8 is 3, and the 0. So close-ish to 30, which our answer was 27 and a bit, so that makes sense. It's really hard for me to estimate with decimal numbers into 22, but remember it's the same concept, just like we did here. If we add sort of that 0 on the end here and make this a whole number, that's exactly what we have done. So our answer, 27.5. One last example. Divide, give the exact answer written as decimal. 806 divided by 24.8. This one's a little easier for me to visualize because I'm thinking, okay, 800 divided by about 25. I'm thinking quarters. There's 4 quarters in 100, so 4 times 8 should be around 32. Okay, but first thing we need to do before we start our traditional algorithm is get that decimal out of our divisor. So I am going to move it over one place. I'm going to take the invisible decimal here and move that over one place, adding a 0 and making a new decimal there. I'm going to rewrite the question. 248 into 8,060. It's a little hard for me to think about. Might have to do some extra work over here, but let's try and work our way through. How many 248s can I take out of, I'm just going to write to 806. I'm guessing 2 or 3. I'm thinking 3. Let's try it over here on the side and see what 248 times 3 is. 3 times 8 is 24, 4 down, 2 up. 3 times 4 is 12, 14, 4 down, 1 up. 2 times 3 is 6, 7. Yeah, that works. So 3. Notice it's above the 6. Be careful about that placement. 3 times 248, 744, minus equals 2, 7, 62. Bring down the 0. How many times can 248 go into 620? I'm going to guess it's going to be 2. Let's see what that is. 248 times 2. 2 times 8 is 16. 6 down, 1 up. 2 times 4 is 8, plus the 1 is 9. 2 times 2 is 4. And 3 would be too big because we know 3 times is that. So yeah, it must be 2. 2 times 248 is 496 minus, that becomes a 1, that becomes a 10. 10 minus 6 is 4, that becomes a 5, that becomes a 1. 11 minus 9 is 2, 5 minus 4 is 1. Okay, decimal, bring down the 0. How many times can I take 248 out of 1,240? This is quite the big question. I'm guessing 248 is kind of like 250. I would guess 250 is like a quarter, so 4 out of 1,000. I'm going to try 5. I almost think it might fit perfectly. Times 5. Let's see. 8 times 5 is 40. 0 down, 4 up. 4 times 5 is 20. Plus 4, 24. 2 times 5 is 10. 12. Yes. 5 on top. 5 times 248 is 1,240 minus 0. And we have reached the end of our question. Our answer being 32.5, which is very close to our estimate of 32. And that's it for this section. Good luck.